derivatives and rate of change. All right, here's something I need to tell you right off the bat. The main reason why I started teaching all these sections is because college students have been coming back to me, old SFIHS alumni that became college students, and they're like, Miss, what is AROC? And I felt so bad because I was like, I'm not sure what you're talking about. AROC stands for average rate of change. Rate of change. All this means pretty much is find the slope. Ta-da! Formula for slope. I'm so sorry I didn't teach this acronym in the past to them, so they didn't know, but now you know. Average rate of change is when you take 2 points, pretty much find the slope. It's called the average rate of change. So now you know what AROC is. Apparently, I think they use this a lot in City College. So if you see AROC, average rate of change, slope. And soon we'll learn that the instantaneous rate of change will be called the derivative. And that's why we've spent so much time in the past few sections learning about limits, because the limit of the slope, so as x and a get so close together, so it's almost 1 point, the secant line will become the tangent line, and that is called a derivative. Okay, it's a type of limit, and that is half of what calculus is trying to learn about, just learning about what a derivative is. All right, so let's take a look at the definition. The tangent line to a curve, y equals f of x, at that point, a f of a, so right here, so if there's a tangent line here, remember the pink line is a tangent line, is a line through P with the slope, this is how you calculate the slope, f of x, so the y value here for x, minus the y value here for a, divided by the x minus the a. So it's just, remember, y2 minus y1 divided by x2 minus x1. It's pretty much it. Except we're taking the limit as x is approaching a. That means x is getting closer and closer and closer and closer to a, provided that this limit exists, okay? So this is true if the limit exists. We start here, closer, 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 until secant line, secant line, secant line, until it's 1 point. Remember, limit, it gets so close. Where does it approach? Approaches the tangent line. So secant line approaches the tangent line. Tangent line is called the slope of the curve. When we learned about slope in the past, it was always for lines, so we never did it for curves. Now the slope of a curve is called the tangent line. Now they changed the definition a little bit. At first they used x, right? But now they're saying, hey, instead of calling this x, which is a different number, we're going to say, hey, here's the distance. It's a, and we're going to go h away from a to get the second point. So we call it a plus h. So literally, if this is 1 and h is 2, a plus h is 3. So just think of 1 and 3, okay? But what they're wanting is to make h 0, meaning a and the point away from it, as it's getting so small, this distance is so small, it's almost 0. So same thing as above. Remember y2 minus y1, y2 minus y1, x2 minus x1. But remember, a plus h minus a, the a's cancel. We're left with the h only, so then we could say limit as h approaches 0. This looks more complicated, but it's actually a more simplified, more beautiful form of how to calculate the derivative. And this formula is what we'll be using from now on every time you're given a function to calculate the derivative. A lot of times people use velocity. I know you guys learned in physics in the past. That is also displacement divided by time, but this is also how you calculate the instantaneous velocity, which is also the derivative. So derivative usually associates with velocity. So yeah, if the function was where the point is, or the displacement, then the derivative is the velocity. And then if you take the second derivative, it usually will be called the acceleration. We'll see that more later. All right, so definition of a derivative. If you see this here, this f prime of a, This is how you read it officially, but we just say it's the derivative. This is called the derivative, okay? The derivative of a. The derivative of function f at a number a, denoted by f prime of a, or you'd say the derivative of a, okay? Remember, derivative of a is f prime of a equals limit as h approaches 0, f of a plus h minus f of a divided by h. Remember, this is what we just talked about earlier. It's just the slope. Relax. If this limit exists. So it looks complicated. We're going to be using it, but mainly just think, hey, it's a slope. I know how to do this, okay? Except we're using limits to do it. So yeah, it gets a little bit more complicated, but you got it. This is exactly the same thing. You can also say f of x minus f of a divided by x minus a. These two are exactly the same thing. We get this from this, so we usually use this to help us calculate because it's much easier. We usually don't have the 2 points, so because of that, we just have the function and we do the plus h. So here is an example of how to solve it. You take the function, and then every time you see the x, you replace it with a plus h squared minus 8a plus h plus 9. This whole thing subtract f of a. So this is just a squared minus 8a plus 9 divided by h. Solve this. What you have to do is make sure you're able to cancel this h. If not, you're going to have 0 in the denominator and you're not going to be able to solve it. So until you're able to cancel that h, you're not done. Once you're able to do that, you can plug in h as 0 and then find your solution, which will be 2a minus 8 because h is 0. So here it's mainly just telling you that the tangent line is going to be called the derivative. We talked about rate of change earlier. First one divided by second one, average rate of change. Instantaneous rate of change is when you add the limit. Without the limit, it's just the slope. You take 2 points, you take the average. When you take the limit, it becomes at 1 point. It's instantaneous. So remember, average 2 points, instantaneous limit and 1 point. That's it for 2.7.